In this video, we will discuss about solar photovoltaic power plant. As an overview, solar power generation is the process of converting light energy from the sun into electricity using solar modules, and this is also known as the photovoltaic effect. PV systems can also be installed in grid-connected or off-grid configurations. Grid-connected configuration is commonly used because it is easier to install and less expensive compared to off-grid PV systems, which mostly rely on batteries. In terms of measurement, there is no commonly accepted definition as to what size constitutes a PV system. Don't believe it? A quick online search reveals a wide range of definitions for each. For a given example, residential grid-connected PV systems are rated less than 20 kilowatts. On the commercial side, commercial systems has an output power range from 20 kilowatts to 1 megawatt and are considered as a form of distributed generation. When it comes to utility scale, we are looking at systems that has an output power that is more than 1 megawatt. A utility scale solar facility is one which generates solar power and feeds it into the grid, supplying a utility with energy. Virtually every utility scale solar facility has a power purchase agreement or PPA with the utility, guaranteeing a market for its energy for a fixed term of time. And the only way to sell solar power to a utility is through a net metering structure, which generally power is used on site and excess power is fed into the grid and purchased by the utility from the producer on a per kilowatt hour basis. This section focuses on solar PV power plant or those that are considered to be on the utility scale. Here we have an example of a ground-mounted PV power plant, and the main components include your solar array. These can be panels or strings. Mounting systems. These holds your solar modules together. Can either be fixed tilt or sun tracking systems. Wirings and cablings, which are electrical wirings that connects all your strings that runs from the array to the inverter. And you also have your cablings related to network and data communications. Skids or pads is a set of assets or equipments that are geographically located in one single area. This would either include 1 or 2 inverters, meters, your low voltage and medium voltage transformers, and it depends on the system design as well as your Metstation. And at the top, you have your grid connection interface. This is collectively known as your substation, where controls are being imposed, as well as electricity is exported into the grid network. Let's discuss about solar array. Solar array would start from a single solar cell. So a solar cell or a PV cell is basically a piece of silicon that was manufactured to convert the energy of light directly into electricity through the photovoltaic effect. Next is the solar module, which is typically composed of 60 to 70 cells in a single assembly. This is a self-contained unit which has leads coming out of it, and modules can be connected together in a series to produce a string of modules. When connected in series, the voltage increases, and on the other hand, strings of modules connected in parallel increases the output current. Please take note that a module is not a panel. A panel is an assembly of multiple modules combined together to form a single unit. Combining multiple panels becomes an array. In general, the larger the total surface area of an array, the more solar electricity it will produce. When you speak of mounting systems, PV modules can be mounted on a structure to keep them oriented in the correct direction, and mounting systems are used to provide structural support and protection. In this example, we have a fixed tilt angle mounting systems. The modules are usually oriented towards the equator with a tilt angle that is slightly lower than the site's latitude. Different tilt angles can be explored to find the optimal power production. The direction that the system is facing is referred to its orientation, or what we call azimuth. The ideal azimuth for a system in the northern hemisphere is your geographic south, and in the southern hemisphere it is geographic north. Sun tracking systems, on the other hand, they may be single or a dual axis tracker, and these systems follow the sun as it moves across the sky. These are generally the only moving parts employed in a solar PV power plant. Axis trackers are used to optimize performance as they allow for panels to track the sun as it moves position throughout the day. However, sun tracking systems cost more in terms of procurement, installation, and maintenance. When we look at the power plant overall, we can see different types of wiring. On this example, we have the electrical side that's going to carry the electricity. The lowest level of electrical wiring is the string level. Usually 10 to 25 modules within a string, and those wires from the modules are connected in series, meaning you have the same current. Then we'll bring all your strings together to a combiner box. Then we move the combined wires coming from multiple combiner boxes into a home run wiring towards the dedicated inverter. That's the image on the right. By design, we are trying to minimize the amount of wire that we have within the array for us to minimize the resistance, as the more resistance eventually leads to greater ohmic losses during operations. Wires coming off of the inverters to the substation, we consider them as high voltage. On the other hand, we also have cablings dedicated for our network communication or data acquisitions. Fiber optic cables are being used for its various data telecommunications usage. These are usually installed between the SCADA Communications Panel on the skid and the substation where your SCADA servers are located. Since Ethernet cables are limited to a maximum length of 100 meters or around 230 feet. Revenue grade meters often use Ethernet cables, while inverters are more into serial communications using an RS-232 or an RS-485. Here we have the skid. A skid is basically a set of assets or equipments that are geographically co-located in one single area. It's composed of your inverters, meters, your low voltage and medium voltage transformers, your SCP or SCADA control panel, and your Metstations, or what we call MDAS. On a PV power plant, data communication and monitoring on the skid level is very important. And this is where your SCADA Communications Panel comes in. These provides SCADA connectivity to your inverters, invert transformers, MDAS, and tracker coordinators. When we talk about inverters, inverters converts direct current or DC electricity generated by the PV modules into AC electricity. They are arranged either in string or central configurations. Central configuration inverters are considered to be more suitable for multi-megawatt plants as it offers high reliability, simplicity, and ease of installations. These are usually 3 phases and can include grid frequency transformers. Typical range for central inverters are from 50 kilowatts to 2 megawatts. On the other hand, string inverters enable individual string maximum power point tracking and required less specialized maintenance skills. String configurations offer more design in terms of flexibility and are usually single phases. The output ranges of these string inverters are from 1 to 25 kilowatts. Please take note that inverters are active equipments, and the PV power plant AC capacity, or the amount of power it can produce, is usually being defined by the total or sum of all the inverters' AC capacity on the project site. We also have meters within the skid. These are passive equipments which does not produce any power. All they do is measure them, meaning you can place as much capacity or inverters behind the meter as needed, as meters does not determine your AC capacity. All it does is measure the instantaneous power in kilowatts as well as the accumulated energy in kilowatt hours. Measuring AC energy delivered by a PV system can be broken into main categories. You have your revenue grade and a non-revenue grade. A meter specified as being a revenue grade is one that meets the requirements outlined in the ANSI standard C-12.1 of 2008, and it is the one required for performance-based incentives such as SRECs or your solar renewable energy certificates. In this section, we will discuss the Metstation. Metstation is defined as a meteorological data acquisition system wherein you only need to measure your weather data. These includes pyranometer for measuring global horizontal irradiance. You also have your wind sensor, which includes wind vane and anemometer, rain gauge, ambient temperature, relative humidity sensors, as well as a barometer. For sun tracking systems, we need to have a reference cell. These are just single cells that are mounted within the array and is being used for irradiance measurements in line with the sun tracking system and not with the global horizontal irradiance or GHI. We also have the back of module temperature sensor, which are mounted in the array as module temperature affects the module's performance during operations. For all those weather data to be collected, you'd have a data logger that pulls data from those sensors and transmit them back into your SCADA system. For a PV power plant, the substation serves as the grid connection interface, which is similar to a POI or point of interconnection between the grid and your power plant. This is composed of your main transformer, capacitor banks, and your SCADA systems. When we talk about step-up transformers, the output from the inverters generally requires a further step up in voltage to reach the AC grid voltage levels. The step-up transformer takes the output from the inverters to the required grid voltage, like for example 25 kV, 33, 38, or even 110 kV, depending on the grid connection point and country standards. We also need to have grid controllers that accepts commands or set points from the grid or the utility if there are needs for curtailment or change the power factor at any given instance and eventually apply them to your PV system. If you need to know more about SCADA systems for PV plants, please check the other presentation and the link should be available at the top. As a summary, solar power plants uses a large number of PV panels that are combined into arrays, installed in an optimal configuration to harvest light from the sun and convert it into DC current, and your inverters used to convert them to AC current before it can be directly used or fed into the electrical grid. The output power of a power plant should be greater than 1 megawatt, and you need to have a substation and control functions. The components of a PV power plant are solar array, mounting systems, wiring, cablings, skid or pads, grid controller interfaces, in which you have your main transformers, your SCADA system, and controllers that are usually located within the substation. Inverters, low voltage transformers, Metstations, SCADA control panels are usually located within a skid or a pad. The power plant substation serves as your grid connection interface. That's all for now. Thanks for watching. If you like this presentation, please hit that like and subscribe button as we dig deeper to those individual sections of the solar PV power plant. Thank you.